Alright guys, so today we're going to talk about linear and quadratic functions. This is probably one of the more important lessons as far as graphing quadratic functions. The linear ones we're kind of used to, we've been graphing them before. However, we're going to talk about some key terms or key things that you're looking for whenever you do this. So linear functions, the slope of a linear function is given as y2 minus y1 over x2 minus x1. Normally we write it in the form y equals mx plus b, which is slope-intercept form, and that m is our slope. Okay, so it's your rise over run. The y-intercept of a linear function is where the graph crosses the y-axis, and we'll have the coordinates 0, comma a. A is going to be a number depending on where it is on the y-axis. The x-intercept or 0 of a linear function is where the graph crosses the x-axis, and we'll always have coordinates b, comma 0, with b being a number depending on where it crosses the x-axis. And recall, slope-intercept form of the line is given by y equals mx plus b. We went over that. However, m is your slope. B is your y-intercept. So it's very important that you know which one's which so you can recognize it. It makes it a lot easier to graph. So find the slope, y-intercept, and x-intercept of the following function. Graph the function by plotting two other points besides the intercepts. We're not going to plot two other points besides the intercepts, but you can. I just don't have a big enough graph to do that. And I'll explain what you're going to do. So this first function says h of x equals 9 minus 9/7 x. I don't know if you guys notice, but this is already in slope-intercept form. It's just written backwards, or not backwards, it mixes up the slope and the y-intercept. Remember, your slope is always attached to the x, so I'm going to rewrite it into slope-intercept form. So now I know the negative 9/7 is my slope. The positive 9 is my y-intercept. So if I graph those, 1, 2, 3, 4, 5, 6, 7, 8, 9, my y-intercept goes up here. I think I plotted it wrong. It should be here. There we go. All right, and now I'm going to use my slope to plot another point. So my slope tells me to go down 9, that's what the negative 9 represents, and then right 7. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9 down, right 7. 1, 2, 3, 4, 5, 6, 7. I don't know if you noticed this, but whenever we plot that other point using our slope, that also ends up being our x-intercept. So you can find the x-intercept by plugging in 0 for the h of x and solving. So if I do that, divide by negative 9/7, divide by negative 9/7, x equals 7. So my x-intercept is 7, aka where we plotted the point. So now I can connect those two, and that would be my linear function. Again, if you're going to do this, you can always keep using your slope to find other points. So I just go down 9, right 7 from that x-intercept, and it'll give me another point. Or I can go up 9, left 7 for the blue point, aka the y-intercept, to get some other points. Okay? B, very important that you understand this one. Okay, it looks complicated. Just split it into two parts. So if I do this correctly, I'm going to say 32 over 8 minus 9 over 8x. Well, I can simplify 32 over 8 to 4 minus 9 over 8x. So now it looks a lot like the one we did above. So if I just rewrite it into slope-intercept form, it looks like that. So again, my slope is right here. My y-intercept is 0, comma 4. So 1, 2, 3, 4. We plot that first. And then I'm going to use my slope. I'm going to go down 9, right 8. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Right 8. 1, 2, 3, 4, 5, 6, 7, 8. That would be over here. You could find your x-intercept by plugging in 0. It's very similar to the one above. You end up getting a fraction though, 32 over 9. It'd be kind of hard to graph that as your x-intercept. So instead we just use the other coordinate, which ends up being 8, negative 5. So I went right 8, down 5 to get to that red dot. And that would be another point that's not an intercept. Okay? So that's the basics of linear functions. Linear functions, sometimes they'll give you properties and they want you to write it. So it says find the linear function that has the following properties. F of 0 equals 8 and the slope of f equals 3/4. So this does show up on the honks. That's why I threw this on here. Guys, remember, this is f of x. So what did I change the x to? Well, that would be 0. So if I wrote this as a coordinate, this would be 0, 8. Well, don't forget, if 0 is first, that is your y-intercept. So that's the y-intercept of that problem. And now I have the slope. So can I write this in slope-intercept form? Well, yeah, I can say f of x equals my slope, which is 3/4 times x, and then plus my y-intercept or minus my y-intercept, depending on whether it's positive or negative. Now, I do remember on the Hawks, they'll give you something like this, and your slope is going to be, a little bit more complicated. Could be like 4/5. Okay, guys, this is a point. My slope is 4/5. This ties back into the Hawks that we've done before. I think it was 2.1 or 2.3. You have to use point slope form to get to slope intercept form, which is what this is. Instead of writing y, we write f of x. Okay? So just keep that in mind. You can make coordinates out of like f of 2 equals 4. So then we get into quadratic functions. So quadratic functions can be written in two forms. There's standard form and there's vertex form. So standard form is f of x equals ax squared plus bx plus c, where a, b, and c are real numbers. Vertex form is f of x equals a parentheses x minus h squared plus k, where h and k are real numbers. So we should note that the graph of any quadratic function will always be a parabola. Remember, a parabola looks like up or downward. Okay, if it's upward, that means your a in both equations, depending on which form it's in, is positive. If it's downward, that means your a is negative. So you need to know that. We kind of talked about it a little bit whenever we do even and odd functions, but we just don't directly say it. All right? So the vertex of a quadratic function is the maximum or minimum point of the parabola. We can also think of it as the point of change between the intervals of increase and decrease. We always denote the coordinates of the vertex as h, k. The axis of symmetry is a line of symmetry that goes through the vertex of the parabola. The sides of a parabola always mirror itself along the axis of symmetry. We denote the axis of symmetry by x equals h. Axis of symmetry is really important if you're going to graph these. Okay? So, I threw in a couple examples. The first one is in vertex form. So we're going to talk about the opening and end behavior. I want to answer all 7 of these questions. Vertex and axis of symmetry, domain and range, x-intercepts, y-intercepts, max and min value, intervals of increase or decrease, and then 2 points other than the vertex and intercepts. So the first one is, does it open upward or downward? So that's what it means by opening, up or down. Well, all you have to do is look at the A. Well, the A is out here. Right? If there's no negative there, that means it's going to open upwards. It's going to be positive. Now, the nice thing is you can use that to answer your end behavior question. So end behavior is based on whether it opens upward or downward. So now think about this. If it's upward, as I go to the left, what's my y value doing? Am I going up or down? I'm going up. So as x goes to negative infinity, aka the left, f of x goes to positive infinity. Talked a little bit about this in the last lesson. Also, if I go to the right, as x goes to positive infinity, f of x goes to positive infinity. The nice thing about quadratic functions is your end behavior, they're going to be the same. They're either going to be positive infinity or negative infinity. It just depends on whether it goes up or down. So if it's upward, it's going to be positive infinity. If it's downward, it's going to be negative infinity. Okay? The next step is the vertex. And the nice thing about vertex form and axis of symmetry is vertex form gives you everything you need without even having to do much work. Your vertex is going to be the opposite of the x, so instead of a negative 4, means a positive 4, and then the k on the outside, which is that negative 1. So 4, negative 1. My axis of symmetry is just based on the x value, so I'm going to say x equals 4. So that's your axis of symmetry. This is going to be your vertex. Okay. Step 3, domain and range. Before I do domain and range, I want to graph my vertex. So 4, negative 1, 1, 2, 3, 4, negative 1. Now let's think about domain and range. As I go to the left and I go to the right, that's my domain. If you think about a parabola, it's going to go on forever in the left and forever in the right. So your domain is going to be all real numbers, or you could write it as negative infinity, positive infinity. That's going to be the answer for almost every domain in a parabola. Your range, okay, is based off of your minimum or maximum value. So this one goes up. So this is the minimum. So this is the farthest I go down. So we always start with the bottom, the down part first. So that would be -1. I put a bracket because I'm going to use -1 all the way up to positive infinity because it's going upward. I'm going to say positive infinity. Now the hardest part, I think, is the intercepts. So to find your x-intercept, you're just going to plug 0 in for y and solve. So I'm going to rewrite the equation. I'm going to say 0, and I'm going to solve it. So I'm going to add 1, square root it, plus or minus 1 equals x minus 4. I'm going to add 4. So my x-intercepts are going to be 4 plus 1, which is 5, or 4 minus 1, which is 3. So that means it's going to cross the x-axis at 3, which is right here, and 5, which is right here. And if you think about it, your axis of symmetry goes through, it's a vertical line that goes through your vertex. So whatever I plot on the left side, aka this point, will be the same on the right side, this point, of that axis of symmetry. So continuing with step 4, my y-intercept is when I plug in 0 for x and solve. So I say y equals 0 minus 4 squared minus 1, which would be negative 4 squared minus 1, which would be 16 minus 1, which would be 15. So 0, 15. That's going to be all the way up here. We're actually not going to be able to graph it on a graph, but it's somewhere around there. So that's how you find x and y intercepts. Now the next step would be your max and min value of the function. So your max, okay, is going to be based off your vertex. So it has to be one or the other. It's not going to be both. It's going to be either max or min. In this case, it's going to be a minimum because it opened upward. So if it's upward, it's a minimum. If it's downward, it's a max. So we have not a max, so I'm going to erase this. We have a minimum. And our minimum value is going to be that coordinate, which is our vertex, so it's 4, -1. Intervals of increasing, decreasing. Well, if you think about it, it's a parabola, right? So as I go from left to right and I'm reading it, it's going down. So it's going to be decreasing from -infinity all the way to my x value of 4. And then it's going to be increasing from 4 to infinity. All right, so if it's upward, it's going to be decreasing then increasing. If it's downward, it's going to be increasing then decreasing. Those don't ever really change. 7, 2 points. Really, guys, all you have to do is think about your graph. All right, so I've used 3 as the x, 4 as the x, 5 as the x. Well, let's use 2. So I'm going to plug in 2 to my problem as x, and I'm going to solve it. So I'm going to get a value of 3. So 2, 3 is the point. Now, the whole point of the axis of symmetry, notice this is 2 left of the axis of symmetry. So if I go 2 to the right and plot a point, you're going to get the same answer. That's 2 other points that you could graph. So it ends up being 2, 3, and 6, 3 that are not part of your x and y intercepts. So then I would connect it just to draw the general shape of the parabola. It's going to look something like that. Okay? So that's vertex form. So rather than me do another problem, because these kind of take a while, it's nice to know the steps. I want you to try C on the notes by yourself and then check it with my notes that I put on Classroom. Okay? So x plus 3 squared minus 4. I want you to check it and see if you did it correctly. So that is vertex form. So then B is standard form. I'm going to let you guys do B after I do D. So I want to do standard form down here. Remember, the first thing we want to find is whether it opens upward or downward. Where if you look at your A, my A is negative. So that means it's going to go downward. It's going to make a frowny face with my parabola. So I'm going to go down like this. Now my end behavior is based off of that. So as x goes to negative infinity, notice now I'm going down, so that means my y is going to go to negative infinity. And I told you whenever we did vertex form that your f of x values are going to be the same. So as x goes to positive infinity, f of x goes to negative infinity. So as x goes to positive infinity, my y goes to negative infinity. Okay, so that's your opening and your end behavior. Step 2 is vertex and axis of symmetry. So this one's a little bit harder because it's not set up for it. It's not vertex form, it's standard form. So axis of symmetry is x equals negative b over 2a. Well, my b is going to be 2, and my c is negative 6, and we'll use that later. But for now, my b is going to be negative 2 over 2 times negative 1. So my x is negative 2 over negative 2, which is 1. So that's your axis of symmetry. Well, the nice thing is you use that to help you find the vertex. Your vertex is going to be 1, comma, something. So now I just got to plug it in and solve it. So negative parentheses 1 squared plus 2 times 1 minus 6. So this ends up being negative 1 plus 2 minus 6, which is going to be negative 5. So my vertex is 1, negative 5. So if I graph that, 1, negative 5, it's going to be right here. Now don't forget your axis of symmetry will help you graph other points. Okay? The third step was domain and range. Remember, domain, I told you most of the time with the parabola is going to be all real numbers, and that's the same case here. My range is going to be this time the bottom, because it's going downward, is negative infinity, all the way up to my y value, which is negative 5 of my vertex. Then you have your x and y intercepts. Okay, so now, when you're doing this, the y-intercept is pretty easy. The y-intercept is just a number at the end of the problem, which is negative 6, so 0, negative 6. So that would be right here. The x-intercepts are a little bit tougher. So normally I would plug in 0, and I would solve it. However, you're not going to be able to solve this without using the quadratic formula. So you would try to factor it if you could. We can't in this case, so we're going to say negative 2 plus or minus the square root of 2 squared minus 4 times negative 1 times negative 6 all over 2 times negative 1. So now we got to simplify our square root because it ends up being negative 20. Well, when you do that, you get 2i squared of 5. So negative 2 plus or minus 2i squared of 5 all over negative 2. And then I can simplify even further. I get 1 plus or minus I square root of 5. All right. This right here is your x-intercepts. Now notice if the parabola is going to go down, it's never going to actually cross the x-intercept. So that's why it's an imaginary x-intercept. So yeah, this one's kind of tough. I know it's not easy, but just keep in mind if your parabola never crosses the x-axis, you're going to have an I in your x-intercepts. Okay? Step 5 is going to be, I believe it's max or min, right? Kind of forgot my steps here. Yep. Step 5 is max or min. So in this case, it's going to be a max because we open downward. So my max is my vertex, 1, negative 5. Step 6 is increasing and decreasing. I told you if it's going to go downward, it's going to start with increasing, and then it's going to go to decreasing. So in this case, it's going to be negative infinity to 1 is increasing, 1 to infinity is decreasing. Again, I just use my vertex to answer that. Now, step 7, I got to find 2 other points that aren't intercepts. Well, one point's pretty easy because I already found the y-intercept, but remember I can mirror it on the other side of the axis of symmetry. So that's going to be 2, negative 6. So then I just need to plug in a number to solve. I'm going to plug in 3. So I'm going to say negative 3 squared plus 2 times 3 minus 6. So I'm going to get negative 9 plus 6 minus 6, so it ends up being negative 9. So 3 negative 9 is 1. And if you use the axis of symmetry, it's going to be negative 1, negative 9 as well. So then I connect it, I make my parabola, it goes downward like we said, so it looks something like that. You can always go back and check your domain and range too after you graph it to make sure you did it correctly. Okay, so that is how you do all that. Again, I want you to try B. It's what we just did now in standard form. Go check the answers with the notes on Google Classroom. I'm not going to do both examples because it just takes too long, but you got to know the differences between the two forms. This is very difficult. If you guys have any questions, please let me know. I'm more than happy to help, especially when it comes to the certify. Your homework is going to be 3.2a certify. Just make